Hi, I'm Dr. CS, and in this video, I'll introduce my professional Python course. So professional Python is a fast-paced coverage of core Python, and it's designed for people who already know how to program. It doesn't have to be in Python, but of course that'll help. And it goes deeper than a typical first course in Python will go, and it's designed to get you ready to become a professional Python programmer. Like all of my courses, the videos in this course are designed to last about 30 minutes. But if you pause the video when I ask you to pause the video and do the active reviews, it'll take you 45 minutes to an hour to get through each of these lessons. Because what will happen with the active reviews is I'll ask you to do something. You'll pause the video and do that thing, write a program, evaluate some expression in the Python REPL or something like that, and you'll learn what all these terms mean. And then when you unpause the video, you'll watch me solve that exact thing. You'll watch me do the active review. And so if you struggled with it, if you had a question about it, you'll get to see me work through the same problem. For each course, there are exercises and projects. Now let me go ahead and show you what I'm talking about. So if we go to the drcs.code's website and we scroll down to Professional Python and view the course, now you should have already done the getting started things. If we click on lessons here, you should have already done your installation of Python and PyCharm. If you haven't, go back and watch that video, which goes over the getting started instructions, or at least the first two steps of them. And then watch this video, which goes through the third step, which is installing and setting up Git. And once you do those, then come back to this video and do Introduction to Professional Python. So these are all the lessons. These are the course materials. So if you see, for example, for course introduction, PFP1, that means Python for Programmers Chapter 1 is the reading for this lesson. Or alternatively, Think Python Chapter 1. Either one of those will work. So there are 13 lessons in this course. Each lesson has a set of slides. If you click on this link, it takes you to those slides. Readings, an exercise that I'll ask you to do after the course, and I'll explain at the end, or after the lesson, and I'll explain that at the end of the presentation. For example, at the end of Introduction to Professional Python, I'll introduce Homework 0 to you. And then some of the lessons later in the course also have projects. Now the projects are longer. Exercises are designed to take an hour or less. And if you go through this course, if you do all of these lessons, do the active reviews within the lessons that I ask you to do, and then between each lesson, so after going through the course introduction, before you go on to the tour of Python, make sure you do homework 0. After you do the tour of Python, do the compounding table exercise before you go on to values and variables. And if you do all of these lessons and do at least one of the exercise, some of these lessons have more than one exercise, then you're going to have a pretty good foundation in Python. If you also do some of these projects, the projects are designed to take anywhere from 2 hours to 10 hours. And they involve looking up things on the web, perhaps installing third-party libraries and things like that. And if you do these projects as well, then you'll be an even stronger programmer. And at the end of this course, you'll be ready to join a professional team as a junior Python programmer. Okay, and altogether, if you do this course, if you do all of the video lessons, run through the slides, do the active reviews, do at least one exercise per course, and you do some of the projects, depending on how many you do, it should take you 20 to 40 hours total to get through this course. And that's roughly half of a university CS1 course, or half of a university course. And if we go back to Dr. CS Codes, I taught a course at Georgia Tech, which was essentially an introduction to data science, which was essentially this professional Python course and this data manipulation course. Now, the data manipulation course I'm still building out because most of these courses are based on courses that I taught at Georgia Tech, but I am reorganizing things and redesigning things for delivery via videos and so on. All right, so Python. So here's our obligatory XKCD comic. Python gives you wings. So Python is a very powerful programming language. It's easy to get started with, and you can do a lot with it. It's a general purpose programming language, which means that you can write any kind of program, you can implement any kind of algorithm, which is different from a domain specific language such as SQL, that's probably the most prominent example of a domain specific language, which is a language that is specifically for manipulating relational databases. That's not a general purpose language. Python is a general purpose language. Python is interpreted. So if you remember from the programming principles course or your CS1 course, there are interpreted languages and there are compiled languages. In a compiled language, you have to compile your source code into some intermediate form, which is either run by a virtual machine, as in Java, or run directly by the operating system, as in C or C++. With Python, you write the source code and then you run the source code directly. Python is a great glue language, and that is probably the biggest strength of Python. It's easy to write programs in Python that glue together different kinds of things. For example, gluing together file system operations with web API operations and maybe visualizations, numerical computing, machine learning, all that kind of stuff. And that's really the killer feature of Python. So you hear people say all the time, for example, that all the machine learning libraries are written in Python. And that's not actually true. They're not written in Python. They're written mostly in C++, C, and in some cases Fortran. But it's easy to write Python wrappers for these libraries so that you can use high performance native code libraries written in these other languages, which are much more difficult to work with. You can work with those libraries in Python, which is a very comfortable language to work with. But one of the coolest things about Python, in my opinion, is the Python name, because it reflects the Python culture. Now, even though so much of the branding for Python actually uses the snake, the Python name actually comes from Monty Python. Python's creator, Guido van Rossum, was a big fan of Monty Python, and so he used Python as the name for his new language. You don't have to be a fan of Monty Python, but it helps, and you can follow this link to see how. Now, why do I even mention this? The reason I mention this is because as you progress in your programming career, you're going to use different languages, and every language, every technology and area has a community around it, and every community has some culture around it. And the culture of Python is to have fun, to be welcoming, and that makes Python fun to use. So, practically speaking, what Python is on your computer after you install it, as you saw in the introductory videos on installing Python, is it's a program on your computer that interprets Python code. So it's a program like any other, and so from the command line you can, for example, type Python 3 -- version, and it'll tell you what the version of Python is. Now, to use Python 3 to execute Python code, there are 3 common ways to do that. One way is to write a file that contains a sequence of Python statements and expressions, and then tell the Python interpreter to run that program. We typically call these programs scripts just because programs that are written in interpreted languages are often called scripts, whereas programs that are written in compiled languages are called programs. You can really use the terms interchangeably, although you wouldn't call a C program a script. But I'll typically call Python programs scripts. You can also execute statements and expressions in the Python interactive shell. I'm going to call that a REPL mostly because I used to program in Lisp a lot, and read eval print loop. REPL stands for read eval print loop, and that's really what an interactive shell does. It reads an expression, evaluates the expression, prints the value of that expression, and then loops back to the beginning, waiting for the next expression to read. All right, and to exit the Python shell, you just type exit. So let me show you an example of that. So if we go to the command line and type Python 3 without any command line options or specifying a script to run, then we get the Python interactive interpreter. And now I can type in an expression. You might think this is a statement, but this is actually an expression. I'll explain why when we get to the lesson on functions. Good lesson here. Okay, unterminated string literal. So I've already made a mistake here. I'm going to hit the up arrow because just like the operating system command shell, Python has command history. What I've done here is I've forgotten I have an opening double quote here, and I forgot to add a closing double quote. So I'm going to add that closing double quote, and now the command works. All right, this is an example of a syntax error. Syntax error is the form of a sentence. So for example, the fact that you have a string starts with some opening quote and then ends with some closing quote is an example of a syntax rule. We violated that syntax rule, and so Python didn't know what to do with print hello world without a closing quote. And I can exit the Python REPL by typing exit or quit. So these are built-in functions in Python. Or on Mac OS X, I can type Control D, and on Windows, Control Z will do that. A third common way to run Python code is in something called the Jupyter Notebook. We're not going to cover Jupyter Notebooks in this course, but we will cover them in the course on data manipulation. They're used quite extensively in data science. And then a fourth way that's not a very common way, but I'll just go ahead and mention it here, is you can use the -C option. So at an operating system command shell, so notice up here, when I was in the Python shell, my command prompt was 3 chevrons. Now I'm in my operating system shell, so it's got my username, my computer name, and my current directory, and then some prompt string. All this together is called a prompt string. If I say Python 3 and use the -C option for command, and then say something like print 2 plus 3, because I just can't remember what 2 plus 3 is, then I get an answer. And sometimes if I have some arithmetic expression that I need to know the value of and I have a terminal open, then I'll just do this real quick. So that's another way that you can run Python code. All right, Since Kernighan and Ritchie's The C Programming Language, which is a classic book on programming, it's been customary for your first program in any language to be Hello World. And if you look on the internet, Hello World, just Google Hello World in multiple languages. The Hello World program is a good indicator of the amount of boilerplate or ceremony, sometimes people say, in a programming language to get a simple program running. Famously, Java, for example, has a ton of boilerplate just to write a program that prints Hello World to the console. So we'll create a file named hello.py and add the following line to it. You can copy this if you want. Yeah, my PDF viewer is being kind of weird here. You can copy this if you want, but I recommend when I ask you to enter things from a slide into your editor, I recommend that you actually type those out. One of the things that I do when I'm learning a new language and I'm going through a good introductory textbook is I type the examples in myself so that the code goes into my brain through my eyes and then flows out through my fingers into my keyboard in the editor. And it sticks better that way. So go ahead and pause the video right here. Create a file named hello.py. You can do that using a text editor or you can use PyCharm. And then open your operating system command shell and execute it with this command here, Python 3 space hello.py. So go ahead and pause the video and do that. Okay, now it's my turn to do it. I'm going to go ahead and use PyCharm, and I'm going to use my Python coursework. Now, in case you didn't run through this before, we have this Python coursework project, and over here in the project panel, I've already created an intro directory, and I have a hello.py file. All right, now if I didn't already have that, let's go ahead and delete that. So I'm just going to click on that, click on delete. Yes, go ahead and delete it. And I'll go ahead and leave the directory there. If I right click on that directory and say new Python file, and I can say, give it a name, hello.py. Now, I showed you how to add things to your Git repository on the command line in the lesson on setting up Git and GitHub. I'll go ahead and let Python or PyCharm do it for me this time. I'll go ahead and let PyCharm do that for me this time. So I'll go ahead and add that. And now I'll enter print hello world and save it. You can configure IntelliJ or PyCharm to automatically save files for you so that you don't ever have to remember that, but I just have a habit of always saving files. As you already know, there are many ways to run that file from within PyCharm. One way is to use this play button up here. One way is to use the Control-R shortcut. So if I do that, then it gets run and we see our Hello World output. Another way to do it is to open this in a terminal. You'll remember from the lesson on setting up Python and PyCharm that I have configured the Control F12 shortcut to mean open in terminal. So that means open a terminal and be in the directory, as you can see here, where this open file happens to be located. And if I do a directory listing, this is a terminal. This is a terminal just like this terminal. It just looks a little different. If I do a directory listing, I see my hello.py and I can run it. Hello.py. Now, remember, of course, if you're on Windows, all of this PyCharm stuff is going to work the same. Your shortcuts are going to be different. And when you run Python from the command line, you're going to use Python, not Python 3 on Windows, unless you're using your Ubuntu shell in the Windows subsystem for Linux. Okay. So now we've written our first Python program. So the Python REPL, as I showed you before, you enter by typing Python or Python 3 and not giving any command line options or a script to run. And as I said before, I call this a REPL. You can call it a Python shell. You can call it a Python interactive interpreter. They're all equivalent meanings. I call it a REPL because that's what it does. It reads an expression, evaluates that expression or executes the statement, prints the result to the console, and then loops back to the read step. We're going to spend a lot of time in the REPL, and especially in the values and variables lesson. But since this course is intended as a fast-paced introduction to Python for professionals, we're actually going to use a different REPL called iPython. So iPython has two modes. It has an interactive shell, so you can use it as a replacement for the Python 3 REPL. And also it is a Jupyter Notebook kernel, and that's really how iPython began. So Jupyter Notebooks are files that get rendered nicely in web browsers. They contain text, graphics, and blocks of Python code, and those blocks of Python code are sent to a kernel such as iPython to be executed, and then the results of the execution are sent back to the Jupyter Notebook for display. We're not going to use that mode in this course, but we're going to use it a lot in the data manipulation course. We're only going to be using iPython as a REPL, and it's a very nice REPL. So we're going to learn about pip3 in a later lesson. But for now, in order to use iPython, because it's a third-party application, we have to install it. And we install it with this command here, pip3 install iPython. So go ahead and do that now. I'll do it as well. So I'm at my operating system command shell, pip3 install iPython. All right, and it's basically telling me that it's already installed for me because I've already installed it. So iPython has a command history just like the Python REPL has, and just like an operating system command shell has, but the command history is much richer in iPython. In particular, every input is part of a list called in, and every output is part of a dictionary. You'll learn what dictionaries are later, called out. Now, you index into a list or a dictionary the same way with square bracket. You can get back to any previous expression that you entered or expression result that was printed out using the in and out variables. So go to your OS command shell and run iPython and just type these in. So make sure you have a web browser open, or you've downloaded the slides, and you can look at the slides while you're watching this video and while you're doing these exercises. All right. So go ahead and pause the video and try these things out. Okay, and now I'll show you how this works. So I'm going to clear the screen so I can start at the top. Run iPython. Here you see the prompt, which looks different from the python.org Python REPL. And I can enter expressions and get the output. I can assign things to variables. So here's a list. And now I can say spices. Now notice that whenever you start typing something in iPython, is if iPython has an idea of what else you're going to type on that line, it presents it to you in this grayed out text. If you want to accept that, hit the right arrow. So your right cursor key accepts that text. And so basically I've just redone what I did before. So now if I ask, what is the value of spices? It tells me. And if I say, what did I enter? What was the second thing that I entered in this iPython session? I can say, give me the value of in sub 2. And when we learn about lists and data structures later, you'll learn why I'm pronouncing this in sub 2. That was the string that I entered. What was the output of in sub 2? Well, if I say out sub 3, notice there was no, or out sub 2, sorry. Notice there was no output for in sub 2. And so when I say, well, what was the output for the second thing that I entered? I get a key error. So you get a key error when you ask for the value associated with a key in a dictionary that doesn't exist. All right. And the reason it doesn't exist is because the assignment statement is a statement, not an expression. It doesn't have a value, and so there is no value to store in out sub 2. All right. But notice that when I asked for the value of spices, I did get an out sub 4 because spices is a variable. A variable is bound to a value, so every variable is also an expression. That means it has a value, and so out sub 4 has that value. And if I say, what is the value of out sub 4? I get the spices. And if I say, is spices actually an alias? That's what the is operator means for out sub 4. That is true. And we'll learn what that means later. Basically, all values in Python, in core Python, all values are actually objects in memory. And so what's actually stored in the spices value is a pointer to that object in heap memory. And the same thing with out sub 4. Now, in iPython, if you want to get help for a function or a module, simply give a name to the thing you want help for and then put a question mark at the end of it. That's the same thing as the help function in the regular Python REPL. But you get a little bit more information from iPython. And if you put a double question mark after the thing you want help on, then it also shows you the source code if it's available. iPython has some special commands that are not provided by the Python REPL and also not part of the Python programming languages called magic commands. All right. And so in iPython, you prepend a %sign to the command and you can run a script. You can get help with a magic command just like you can anything else by putting a question mark after it. And you can get a list of all the magic commands with %ls magic. So let me show you that run here, that run magic command. So I'm back here in iPython, and I'm not sure where I started iPython, so I'll do a pwd for present working directory, and it tells me I'm in my home directory. So that's not where I stored hello.py. I stored hello.py in my Git repository for Python coursework. So I'm going to go cd. I could say %cd, but as you'll see in a minute, some commands are Automagic, which means that I don't have to put a % in front of them. I'm going to go to VCS, github.com, Dr. CS codes, because this is where I put it as I explained in the lesson on Git and GitHub. And Python coursework, and then I actually put that in the intro. Python coursework. Yeah. And then it's in the intro subdirectory of that. So now if I do an ls, I see my hello.py, and I can run hello.py. All right, so I can actually run scripts from within iPython. So iPython is such a rich environment that you can really sort of live in iPython. And for shell commands that don't have magic commands associated with them, you can actually execute them by prepending a bang. So programmers often pronounce the exclamation point as bang. Now, a minute ago, I showed you that I was not in the right directory from which I could run my hello.py file, and I did a cd command, change directory command, to get to it. Now, if I want to go straight to that directory easily, I can bookmark it. So the way that works is, so if I do a pwd, I'm in the intro subdirectory of my Python coursework directory. And the Python coursework directory is the root directory of my project. So I'm going to go up one, cd space ... Now I'm going to copy this. So I'm going to select it and copy it with, let's see, that's Command C on a Mac. It would be Control C on Windows or Linux. Now I'm going to say bookmark. And I want to call the bookmark, how about just Python coursework. And then after that, I'm going to paste the actual location of my Python coursework repository. Now, I'm going to do cd just to demonstrate how this works. I'm going to go back to my home directory. If I say cd and I don't give it a directory to go to, it just goes to my home directory. But now I can say cd Python coursework. It auto-completes because that's a bookmark. And now I'm in my Python coursework directory. All right, so a nice time-saving feature there in iPython. All right, so I've already explained how Automagic works. You can actually turn that off if you want by toggling it with the %Automagic command. And I suppose you would want to do that, for example, if you happen to use one of these Automagics, like say you have a variable called pwd and you don't want to use Automagics and you don't want to confuse yourself, then you might want to turn off Automagics. So iPython is nicer than the python.org REPL, but as we'll learn in a later lesson, doc tests use the python.org REPL prompt, the 3 chevrons. So for writing doc test examples, iPython offers the doc test mode magic. What that does is if you say doc test mode, it changes your prompt to the Python REPL. So if you need to document something like, let's say def add AB, return A plus B, let's say that you're writing this function in a script and you want to add doc tests to the doc string for that function, then you could still use iPython, go into doc test mode, and then you could say, okay, so here is an example, add 2, 3, and get the result, and then you can copy that and paste it into your doc string. And then when you're done, you can simply say doc test mode again to toggle doc test mode and get out of doc test mode. All right. So there's a brief introduction to iPython. I can get out of it with exit or Control D and so on, just like the regular Python REPL. And that's the end of this lesson. Now you've been introduced to Python. It's kind of a short introductory lesson. Python, just to wrap up, it's an interpreted general purpose language. You can run Python code as scripts contained in files or or interactively in a Python REPL, such as the Python program itself or an iPython. Python's a great glue language and it's a lot of fun. All right, so now that we're done with this lesson, what you should do now before you go on to the next lesson, go to Professional Python and look at the lessons, is you should do this exercise. I call it Homework Zero. I used to assign in all of my courses at Georgia Tech, I used to always have a Homework Zero assigned in the first week. And the whole point of Homework Zero is to make sure that everybody had their computers set up to be able to do the rest of the coursework. So it's an easy grade and it's a way to make sure that you have everything set up correctly. So basically what you're going to do is you're going to make a directory to hold your Homework Zero coursework. One thing you might want to do is just use your Python coursework. So if I went to my Python coursework project in PyCharm, I would come to the root, right click, and say new folder or directory and call it Homework Zero. All right, now I have a place to put it. So make a place to put it, but then go to a command line and execute this. So you already know that Python or Python 3 -- version will give you the version of Python that you're running. Now, what you might not know yet is that this symbol here is a redirect. So when I execute this, it's going to redirect the output. So instead of being printed to the console, it's going to go into this file. So I want this file to be in my Homework Zero directory. All right, and it's all explained right here. Then the next step is you can do this in PyCharm to basically enter all of this code here into a file called nimbly_bimbly.py. So if I went back to PyCharm, in my Homework Zero directory, I'd say new Python file, nimbly_bimbly.py. Go ahead and add it to Git. Paste what I copied. Well, that's not what I copied. I thought I copied that. Let's actually copy it with Control C, or I say Meta C. It should be Command C. I say Meta C because I used Emacs for most of my life, and Emacs calls the Alt key or Command key the Meta key. All right. Now, I'm not going to run this because I will leave that suspense for you. But once you enter this, now you're going to run that program. And then you're going to redirect the output to that same file, that same homework zero-output.txt. But this time you're going to use 2 right angle brackets, not just 1, because the 2 right angle brackets, or 2 greater than symbols, appends to this file rather than overwriting it. All right. And after you do that, go ahead and look at homework zero-output.txt, and you should see the version of Python that you're running. and the output of this program. And that's it. So have fun with this exercise, and I'll see you in the next lesson.